Hi guys, today we're going to be continuing to review Algebra 1 topics. Today we're going to look at factoring, solving absolute value equations, and we'll be solving quadratics using something called the zero product property, or ZPP for short. Alright, so first up we're going to take a look at factoring. Remember yesterday we did some factoring with the GCF, the greatest common factor. We are still going to look for the greatest common factor whenever we are asked to factor something, but today we're going to extend now to factoring binomials and trinomials. Remember, a binomial is an expression with two terms, and a trinomial would be an expression with three terms. So in problem number 1, we're looking at a binomial. Now, at first it looks like number 1 is not factorable because we can't pull out a GCF from x squared and negative 16. However, this is something special called a difference of squares. Okay, I'm going to abbreviate that as DOS, so difference of squares. You might remember this phrase from Algebra 1. Okay, because you should have factored difference of squares before. But let's briefly talk about what that actually means. So difference means you're subtracting. See how we have that subtraction sign here. Now we're subtracting two squares. This is x squared, and this is the quantity 4 squared. So that's why it's given the name difference of squares. Sometimes it's called the difference of two squares. Now whenever we factor an expression that is a difference of squares, we're always going to create two different binomials. Now inside these binomials you're going to place an addition sign and a subtraction sign. It doesn't matter the order. You could have placed a subtraction sign and then an addition sign. It really makes no difference. But then to figure out what terms are going to go inside that binomial, what you're going to do is look at the first term and you think of what squared gives you x squared. Well, that would be x. Okay, so x squared gives me x squared. Now 4 squared gives me 16. So that's what I place here and here. X plus 4, and the other term is x minus 4. Now, just to show that this is in fact the factors of x squared minus 16, remember if you multiply this back out, you should end up, if you FOIL this, with x squared minus 16, and in fact you do when you multiply those both together. So that means it definitely factors into x plus 4 and x minus 4. Alright, now moving on to example 2. Let's think back to Algebra 1 when you factored trinomials of this form. Now notice that the lead coefficient here is 1 in front of that x squared here. Whenever you have a lead coefficient of 1, when you factor this, it's pretty basic. What you're going to do is find two numbers that will multiply to 12, but will add up to 7. Okay, so what two numbers multiply to 12 and add up to 7? Well, those two numbers would be 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So we have to make sure all the signs are correct, all the numbers add up and multiply correctly. But that gives us our two binomials. We're going to use the numbers 3 and 4 now to set up our two binomials. So we have one binomial, x plus 3. The other binomial is x plus 4. Okay, so that's just a very quick review of Algebra 1, factoring a trinomial. I would like you guys to try example 3 on your own, and then you can go ahead and check with the key. Alright, so hopefully you guys paused the video and you checked your answer to number 3 with the key. I hope you did get it correct. If you remember a lot of this from Algebra 1, that's great. If you don't remember it, don't worry about it. You're going to get lots of practice tomorrow in class, so you can ask lots of questions as well. We're going to move on now to example 4, and example 4 is a lot more difficult than example 2 because we have a lead coefficient here that is not 1. Here we have a 6 out in front. So this does change the way we factor here, okay? So we call this method splitting the middle term. You might remember your teacher teaching you this last year. This is a little bit more work than what we just did factoring the other two examples. And I like this method because it's a foolproof method. If you follow the steps correctly, you'll never get an example wrong. I like to call this the X method also. And the only reason why I call it the X method is because I use this X to kind of organize our work. That's about it. There's really nothing special to this method. I just call it the X method. So what we're going to do first, the very first step is really crucial here. You have to multiply the first number and the last number together. We end up with negative 18. Okay, I place that at the top of the X, and then I place the middle number here, this negative 7, at the bottom of the X. Okay, and again, the X really isn't special. It just kind of organizes your work. You could do this in your head as well. Now, your goal is to find two numbers that multiply to negative 18 and add up to negative 7. So you want to find numbers that will multiply to negative 18 and add up to negative 7. Okay, those two numbers would be negative 9 and positive 2. So really, once I have these two numbers, these are actually irrelevant. I'm really just looking for negative 9 and positive 2 here. Okay, so what I'm going to do is pause and kind of clean this up a little bit so we have a little bit more room. Okay, so we've got our two numbers, -9 and 2, and even if you wrote those two numbers as 2 and -9, it would not affect the problem at all. You would still get the same result. It might look a little bit different as you factor, but you would still get the same answer. So don't worry about the order of the two numbers that you select, okay? Now, the reason why it's called splitting the middle term is what we're going to do here is actually split this -7x here into two different terms using -9x and +2x, okay? So what happens is the first term and the last term, they stay the exact same. So we just drop those down, okay? The middle term, we split it into -9x and +2x. So as you can see here, that's why it's called splitting the middle term, but we really haven't changed the problem at all. We're just rewriting this term here a little bit differently. It's like taking 5 and rewriting it as 2 plus 3. Okay, it's not really changing the value, it's just rewriting it a little differently. Okay, now at this point, here's where we start factoring. We're going to take the first two terms here, we're going to group those together, and we're going to take out the GCF. Now the GCF between 6x squared and -9x would be 3x. So left over, I have 2x minus 3 in parentheses. Now I do the same thing for the other two terms. I take out the GCF here. Now the GCF here, there isn't one, but you always have to pull something out. What you're going to do, if there's no GCF, pull out a +1. Okay, it might not make sense why we're writing it like this right now, but it will in a second. So we have to pull out something. We're going to pull out +1. We're left with 2x minus 3 inside those parentheses. Now at this point, it's a great checkpoint because you can see here, since I have the same exact parentheses, I am doing this correctly. If these are different in any way, somehow you did something wrong. You probably messed up with the original two numbers that you picked, so you got to go back and restart the problem. So at this point, I know I'm in good shape because I have the exact same thing in both sets of parentheses. After that, it's pretty basic. You're going to take that GCF, those two that you pulled out, and you're going to put those together. So if you had not written anything in here, you might think that there is nothing to pull together. That's why you have to always pull something out. Always pull out a +1 if you don't find a GCF. And you're going to rewrite that as a binomial, 3x plus 1. So I just took 3x and +1 and I put them together here in that binomial. Okay. Now for my other binomial, I simply write 2x minus 3 only once. Okay, so you don't repeat it twice, you just write it once. These are actually the factors of your original trinomial here. Okay, if you wanted to multiply it all out just to double check, you would get the exact same expression here, 6x squared minus 7x minus 3, which indicates that these are definitely the factors of the original trinomial. Okay, at this point, I would like you guys to pause the video and try example 5. And example 5 is definitely just like example 4 because, once again, we have a lead coefficient that is not 1. So we have to split the middle term in order to factor number 5. So if you're not comfortable quite yet with the steps involved in splitting the middle term, I would suggest replaying example 4 one more time before you attempt number 5. So go ahead and check with the key. You're doing a great job so far. All right, so let's move on now to absolute value equations. This can be a very tricky topic for students, but really it boils down to a very basic concept. When you're looking at absolute value, remember anything inside the absolute value bars become positive once you take them out of the bars. So if we're trying to solve an equation like the absolute value of x is equal to 3, we actually have two distinct cases. X can either equal +3, and it can also equal -3. Right? Because the absolute value of -3 is 3. So we have two distinct cases here. The same thing applies to when we get a little bit more complex with an absolute value equation. The inside here, for example 6, can either equal 2, or the inside could equal -2, and we'd result in a true statement, right? So we have two different cases here. Either the inside, so this x minus 5 is the inside of the absolute value bars, that can either equal +2 or it could equal -2. So you need to always make sure you set up two distinct cases, okay? Really important. A lot of students will solve this completely as if it's not an absolute value. They completely forget to set up the second case. You have to make sure you set up two different cases. So when we solve this, it's very easy from here. We end up with two unique solutions. X is equal to 7 and x is equal to +3. So notice our answers are not just 7 and -7. I will see this often as an incorrect mistake here. Please make sure you don't do that. You need to set up your two distinct cases and then solve them accordingly. All right, now let's take a look at example 7. When you see this absolute value equation and the bars here are not alone, so in other words, there's other numbers outside of those bars, you need to make sure that you isolate the bars first before you set up your two separate cases. So this is really important. We need to isolate the bars in an absolute value equation every time. So we'd have to add 10 first. Okay, so we'd have this equation here. And then we'd have to divide by 3. So we have the absolute value of 2x plus 5 is equal to 10. It's important that you keep the right notation written as you go through the problem, so make sure you don't drop those absolute value bars too soon. Okay, now at this point, it looks exactly like problem 6. At this point, we can now set up our two different cases. So you have to wait to set up your two cases. So we have 2x plus 5 can either equal positive 10, or 2x plus 5 can equal negative 10. And from here, we would solve. So we have x would equal 5 halves. Or we have x would equal negative 15 halves. Okay, so here are our two distinct answers. All right, and finally we have number 8 here, which is actually a little bit of a twist on absolute value equations. In this case, if you try to isolate your bars here, you'd have to divide by negative 2, and you end up with the absolute value of x minus 4 is equal to negative 3. Now at this point, you really have to stop and think. Think about what absolute value does. It always makes the inside positive, right? So once we drop those absolute value bars, this quantity is supposed to be a positive value, which means it could never equal negative 3. So this actually has no solution. Okay, there is no possible value that you can plug in for x that once you plug that in, you'll get a negative 3 after you take the absolute value. So a rule of thumb is whenever you see the absolute value bars here, it doesn't matter what's on the inside, equal to a negative number, you're always going to get no solution. Okay, so be careful if you have your absolute value bars isolated like we do here, and you end up with a negative on the other side of that equation, there would be no solution to that problem. Okay, next up we're going to talk about solving quadratics. So just a brief review. When you learned this in Algebra 1, you would have learned 3 different methods for solving a quadratic. You would have solved the quadratic by factoring and using the ZPP, the zero product property, which is what we worked on factoring here at the very beginning of this lesson. You would also have used the square root method, and we'll do that on the back side of your notes. And you would have also used the quadratic formula. Now we're not going to use the quadratic formula in this particular lesson, although we will use it this semester, so later on we're going to get to that. Now you know you're dealing with a quadratic when you look at an equation and you have a variable squared. That means you're dealing with a quadratic. So in order to solve this quadratic here, this particular problem, we would want to factor it. Okay, this is a trinomial. It looks just like the problem above at the very top of our lesson. So what we're going to do is find two numbers that multiply to 8 and add up to negative 6. Those two numbers would be negative 4 and negative 2. Now what we're going to do is use the zero product property, the ZPP. Okay, and basically all that is think of this equation here. A times B is equal to 0. Well, if you know that A times B is equal to 0, then you know that either A has to be 0 or B has to be 0, or both of them could be 0, right? But you know for sure that either one of those must be 0. So that's the exact property here that we're going to apply in order to solve. We know that either x minus 4, that quantity, has to equal 0, or x minus 2 has to equal 0 in order for this statement here to be true. So once we solve, we end up with two distinct solutions here. Either x could equal positive 4 or x could equal 2, and we would get a true statement. Okay, next up, number 10 is a little bit different than number 9 because here we just have a binomial. Remember, the first thing you always want to do is try to factor out a GCF. So here we can see that a GCF would be x, so we're left with x times x minus 4. Okay. Now, right away we can apply the zero product property. We have it written as a product, x times x minus 4. So now we can break this up and say, well, either x is equal to 0, so this quantity here is equal to 0, or this quantity here is equal to 0. So we're directly applying the zero product property. So now we have one solution, x is equal to 0, and over here if we solve, we end up with x is equal to 4. Okay, so again, always make sure that you try to take out a GCF first. Now for number 11, this problem's on here because a lot of times students make this really difficult for themselves and they try to multiply out all these terms. But remember, you want to solve this by using the zero product property. That P here stands for product. We already have a product. This is something times something times something, so that's a product. So right away we can apply the zero product property here. We can say that either x is equal to 0, x minus 3 is equal to 0, or 2x plus 5 is equal to 0. Okay, and from here we end up with three different solutions. We have one solution, x is equal to 0. We have another one here, x is equal to 3. And here, if we solve, we end up with negative 5/2. All right, next up we're going to look at the square root method. Now, this method is probably the method that you'll like the most because it's the quickest, but it doesn't always work. You can't always use the square root method. So for example, the problems above that we had to factor, we can't use the square root method because we have a linear term. So we have this term here with just a single x on it. You can't use the square root method if you see a problem like that. But in these next two problems, you can use the square root method, and we'll show you how. So you want to isolate your variable when you're using the square root method. So for example here, we would divide by 4 first, then we can go ahead and square root both sides. Once we do that, you have to make sure you're really careful here. You end up with two unique solutions. Remember, it's a quadratic, so we should have two solutions. One is going to be positive 3, and one is going to be negative 3. 3 squared gives me 9, but also, negative 3 squared gives me 9. So the quantity negative 3 squared will also give me positive 9. So there are two unique solutions. Make sure you don't forget the negative here. All right, now in number 13, let's go ahead and try to isolate our variable. We have x minus 3, the quantity squared, is equal to 16. Don't make this harder on yourself and try to multiply that out, because right away you can actually just take the square root of both sides. Now in this case, we're left with, on the left-hand side, x minus 3. Okay, so when we square root the quantity x minus 3 squared, we end up with just x minus 3 on the left-hand side. On the right-hand side, though, again, remember, we have two unique cases here. It's going to be positive and negative 4. So we have x minus 3 equal to 4, as well as x minus 3 equal to negative 4. So we have two solutions here. X is equal to 7, and x is equal to negative 1. Now this is something that you might not remember quite as clearly from last year, but that's fine. You guys can just go ahead and pause and replay this if it's unclear still, and you'll get lots of practice in class tomorrow. All right, we're going to move on now to the final topic of today's lesson, and that's solving radical equations. We're actually going to leave simplifying radicals and solving literal equations for in class tomorrow. So let's focus now on solving radical equations. So whenever you see a square root symbol, you're solving a radical equation. This is referred to here as a radical, okay? So to get rid of that radical and to isolate x, we have to square both sides of the equation. So you have to do the same thing on both sides of the equation, so we're going to square on both sides. We end up with x on the left-hand side, and 9 squared is 81. This is my final answer here. Now notice, my answer is not positive and negative. A lot of students will try to do that, but this would be incorrect, because think about trying to plug in a negative number into a radical. You can't do that, right? You should remember that from Algebra 1. You can't have any negative values. You can't take the square root of a negative value. So moving on now to number 15. Again, if we want to isolate x, we have to get rid of this square root sign first. So the first thing we're going to have to do is square both sides of this equation. So we end up with x plus 3, because those square root and this squared here cancels each other out. So we're left with x plus 3 on the left-hand side. And on the right-hand side, 4 squared is 16. We can now subtract 3, and we end up with x is equal to 13. So that's my final solution here, and that's actually the end of today's lesson. So very nice job, guys. Make sure you come into class ready to ask questions, ready to work, and then we'll work on the next two sections of this notes in class together. Okay, nice job. See you tomorrow.